Hi everyone, do you hear me?
Hello.
Yes. Okay.
So I'm going to send you link to Google Form. It's kind of a text test for CNNs for previous lecture that you have. This please complete test and say me if you're ready. I think we will wait for 5 minutes. Everybody will come to to Zoom meeting, sorry. And then we'll continue to explain all the tasks which was in the test and refresh our knowledges. Okay, I think 4 minutes and we will start explain answers for the test. Okay, are you ready?
Yeah, ready.
Okay, so in the first question we have 3 options which connect with batch normalizations, sorry. So the correct answer is second one. And let's explain why first and third are not correct, incorrect options, and why second one is correct. So option one says that batch normalization stables the distribution of observations, allowing the model to use a higher learning rate without incorrecting issues like gradient explosion or yeah, that's it. So because of this, it's incorrect option. But second one, we can say that by normalizing the input to each layer, batch normalizations makes the training progress smoother and more stable, which enables the use of higher learning rate and because of this makes the fitting process more stable, so the learning rate can be increased. It's the correct option. The third one was option do not affect the learning rate it anyway. So while batch normalization doesn't directly change the learning rate, it does make it possible to use higher learning rate. Because of this, indirectly affecting the training process. So is it clear?
Yeah, it's clear now.
Okay.
Thanks.
So in the second question, we have different filters in convolutional layer output R. Here we can say that the first one is correct because each filter in the convolution layer produces its own features map, and these feature maps are stacked along the channel axis, forming the output tensor. Second and third one are incorrect because in the second option, the filters do not add a new dimension. Instead, they increase the number of channels in the output tensor. And in the third one, the feature maps are not averaged into a single matrix, and each filter produces a separate feature map. Okay, let's talk about pooling. here we have 3 options which we can choose, and all of them are correct. Because the first one correct because Pullen reduces the spatial dimensions of the input. For example, is reducing the image representation size, and this lowers computational complexity and retrains the most important features. In the second one, Pullen increases the model's invariance to small shifts, and in the input image, making the convolution layers more robust to changes its object's position. In the third option, we have average Pullen. So average Pullen can be viewed as a convolution operation with a fixed kernel where all weights are equal. Okay, and in the fourth question, we have reversion the sentence. Here we can say that, one second. Okay, the second one will be correct because in the first option, convolution networks are not sensitive to the sequential order of input elements. They process data in the spatially invariant manner. So and in the second option, one directional RNNs process sequences in the specific order. It's left to right or right to left, and reversion the sentences sentence changes the sentence of information presented at each time step, those affecting the RNN's behavior. And the last one was question about select on all the correct statements. Okay, here we can see that first and third one are correct options, and the middle one will be incorrect. Why first one is correct? Because convolution networks can be parallelized effectively because the convolution operations at each layer are independent of one another. The second one about RNNs is incorrect because process sequences in step-by-step manner, where each step depends on previous one, and it making parallelization difficult. And in the third option, maximum over time Pullen selects the maximum value across the time dimension, allowing the model to handle variable lengths input data without requiring padding. So do you have questions about all stuff which we had in the test? Okay.
May I ask you to go back to the second question and explain it again, because I didn't quite get it. Yes,
Okay.
please. One.
So here we had question about different filters in convolution layer output are. First option was stacked along the channel, stacked along new extra ASICs, and averaged into only matrix. So what was unclear in the explorations?
The second option, why about the new extra axis? Why is it invalid?
Okay. So when we stand alone extra axis, we don't add a new dimension there. we just increase the number of channels in the output tensor.
Okay.
What did you think? Why we can say that it is correct option? If
Well,
not it's clear, we can just move to the code and it will be okay.
yeah, it's okay.
Okay, so
It's just me.
okay. Okay. Let's begin today let's begin view of code today. We have implement we have code about convolution networks. And we will not only implement the CNN model, we will also understand which step is necessary. We begin by importing essential libraries. Each library has a specific role in our workflow. Let's begin with exploration why each library is necessary. The first one is matplotlib. We need to use it to plotting all the graphs. I think it is common for you because we had it on previous lessons, and I think you have had it on different machine learning courses. Also, it is NumPy and pandas. Okay, NumPy because it's a fundamental library for numerical operations. We will use it today, and pandas we will use for create data frames. Also, we enable % mark and matplotlib inline to ensure that plots are displayed directly within the notebook. Okay, let's run this code fragment and move on. Okay. Next, we download the dataset using curl command. This dataset contains job descriptions, and our task is to predict salaries based on this this data. So then we will load into pandas data frame and inspect its shape to understand the structure of dataset. Data frame is two-dimensional data structure similar to an Excel spreadsheet. I think it's common for you. Let's move next. We create here a new column, log salary. You can see it here. By applying the natural logarithm to salary normalized, you can see it here, and you can see how we use logarithm operation with NumPy library. This transformation helps stabilize variance and reduces the impact of extreme values, making it easier for the model to learn. Okay, can you explain me why we need a logarithm here? Why it is common technique for normalizing? Okay, it's if nobody can say it, I will explain. We can take logarithm here because it's common technique for normalizing data when the data spans several orders of magnitude. And it ensures that our model isn't overly influenced by large salary values. So we can go next, and I think we will move on for data processing. Text and categorical data need to be prepared before feeding them into the model. And we define columns for text features. We can see it. Here in the code. We have categorical features too and target variables. So you can see it in order like I explained. Here's text columns, categorical, and target. Targets here. So then we handle missing values by replacing them into none, like fill missed variables. I think it will be more correct to say it in this way. And can you explain me why it is necessary to fill missed variables?
Missed variables will probably cause computational errors when we're doing some mathematical operations with them. Since if we encounter nan value when computing something, we will get nan as answer.
Yeah, exactly. It's like this. So next we can see. Okay, let's run this script. Then move on here. It will print all the information. And then we will have an LTK library. We had it on previous lesson. So let's talk why we need this library in our code. We normalize text data, and here we tokenize the text using an LTK library, breaking down sentences into individual words. And tokenization, we had tokenization on previous lesson too. Maybe you will explain me why what tokenization is, why it is necessary to have it in our code. Maybe some other moments. I wanted today have conversation with you because all the time I just talking and you are listening. So maybe we will have conversation today.
I can give it a try.
Okay, okay, go on.
Tokenization, actually split the sentence into, let's say, into smallest elements that cannot be split further. So usually there's words. So sentence is split in words, but also tokenization can do additional operations like, filtering some not very useful, stuff like punctuations from the sentence.
Yeah. So I agree with your explanation. It's a kind of process of converting text to meaningful units, I think, because in the state of art or prog, we have split not for words to just elements which connects of the byte operations. So yeah, and here we have normalization function. We convert text to lowercase in lowercase ensures uniformity. We're reducing the number of unique tokens. So yeah, okay, let's go on, and then we can start this previous code fragment. So here, yeah, we need to fill some code in this code fragment. So we create a dictionary of token counts. The step identifies the frequency of each word in the text columns. And no, so okay, give me 1 minute. I will understand if have we this code later or not. We have, it seems like we have this code later, and we don't need to do anything on this step. It's confused because sometimes we have comments in code, but we don't need to do anything because we have it later. So okay, everything is good, and later we have fragment. Okay, why do we use all these fragments? It's understanding word frequencies. We have graphics here. So it helps identify common and rare words, guiding vocabulary creation, and ensuring our model doesn't waste resources on infrequent tokens. And then we can filter out words that appear less than 10 times. Here we have constant value for this. Because this is are often unimportant or noisy sequences in our data set. So by removing rare words, we reduce the model's complexity and improve its generalization ability. This step also prevents overfitting, where the model learns patterns specific to the training data, but fails on unseen data. Here we can see that we add UNK token and path token. So it means that we add unknown token and padding token to handle out out of vocabulary words and ensure consistent sequences length. We understand that unknown token replaced with words that we haven't seen during inference, and path helps in maintaining uniform input sizes for batch processing in neural networks. Is it clear for you, or did you did you meet such such tokens in the train loops? I just worry if do you have questions or not? Because maybe some information was unclear. Quick.
Yeah, it would be good if you tell more about these tokens. Thanks.
Okay, so we have pod token. It's like podding. We need it because we have batches on the training, and I think it's similar for you. What is batching and why do we need this in the training loops? So when we want have more than one sequence on the process, would it be inference of train? It doesn't matter. We need to connect all our sequences in the batch, and then we will have metrics. But we can't create metrics if we'll have not not equal sizes in all the sequences. Because of this, we need create equal sizes, like equal lengths all of sequences. Because of this, we can put part token in the end of sequences to create metrics, and because of this we can use batching on our processes. Is it clear for you, or I can draw it for you?
Yeah, it's clear. Thank you.
Okay, and unknown tokens, it's okay. Why do we use it? Now in 2023, 24 years, we have state-of-the-art approaches, and we have tokenizers, which allows us not split our text into words, or we split it in byte pairs fragments, and because of this we cannot use unknown tokens. But previous years, when I split it into words, we wanted to have we wanted to have token which will be allowed us to put it when we hadn't this word in the vocabulary on train, but we have it on inference, and because of this we need to recognize what is the word, and don't stop training operation. So because of this we want to use unknown token also.
Okay, thank you. It's clear.
Okay, good. So then we had we mapped tokens to unique UIDs to create a vocabulary. We had this fragment on previous lesson too. And also we need to convert. Oh my God, what is here? So something gets it's not good. Okay, let's see what is going on. We can see a length of token ID and length of tokens. So it's not equal, but why it was like this? tokens. So I just ran code not in the direct operations. I don't know what was it. Okay, so to train our model, we need to convert the sequences of text into matrices of token IDs using as matrix function. It's we can see it here, and neural networks operate on numerical data. So converting text into numerical form, I mean matrices, is crucial. And I explained you why do we need pattern, because it's ensure all sequences are the same length and allowing us use batching processes. And here we can see all of information about our matrix. So, okay, we have we vectorized all of our data. So now we need to implement convolution network, and we will start do it. We use Torch library for this. We built a simple feed-forward neural network with embedding layers. We can see this code here. So we just need embedding layer with we imported from Torch library. We pass tokens len, like it's like a vocabulary size. We need to provide for our lawyer vocabulary size of our tokenizer and hidden dimensional, because embedding matrix would be a matrix with dimensions of x and y. Can you explain me what will be dimensions here for x and y? Is it clear for you? What will be in the x dimension?
So our embeddings will be of size 32, and as input, it will be. I actually didn't get it. This is length of our all number of our tokens. So this is length of our vocabulary.
Okay, I want to show you what it will be. So we will have something like, I want to draw you in the markdown. That will be okay. You see that it will be matrix. 1 second. Okay, let's imagine that it is matrix and you see it, because I don't know how to create it more beautiful. So here we have x dimension, and here is y dimension. We know that okay, which dimension would be 32? What do you think?
This will be y. Why?
Yeah, you are right. It's hidden size in our model. What we will have here, you can say that, okay, you can pronounce not a variable, you can pronounce just what it would be, like length of something.
length of tokens. So yeah, I think I get it. So our input will be one. So it will signify us a particular token in our vocabulary. So one for the some element in our.
Yeah. So I think now it's clear for you. Yeah, it will be in this way. Oh my God. So yes, and in state-of-the-art architectures, embedding sites are like this, like in this manner. They have dimensions like this. It's metrics, and when we will have next lessons, we will have conversation about BERT architecture, about transformer architecture, and others. So this dimension always consists of hidden size of the model, and this dimension always consists lengths of vocabulary cup of our tokenizer. And it can be different types of tokenizer. It can be a sentence piece, it can be a word piece, and others. But it will be like this all the time. So, okay, if it's clear, let's move on. 1 second. Okay, we had make batch. We had this code. No, we have matrix. Okay, let's see where we will use matrix. Okay, we provide this function to our embedding layer, and then we have function for batching in our neural networks. So we use here unknown tokens and other stuff which we had. Also, we provided a function for dropout in our convolutional networks. So we can provide this code here, and we can run it and see what is going on here. So we provided to make a batch function first 3 first samples from our train dataset, and we split it sequences what was less than 10 lengths. So we have output in this template. Okay, if all the code what was in previous fragments is clear, we can move to 1 second. Yeah, so our final task will be complete code. We can move on, and we will talk about implementation of convolution network. So we have here class of flatten and reorder. I want to explain you why we need all the layers which we have here. First, we can explain, we can talk about embedding layer, why do we need it, and in the convolution networks. First, let's convert token IDs into dense vectors, capturing semantic relations between words. Also, we need convolution layer. I don't see it here. Oh, okay, here, yeah, here we have it. So why do we need convolution layer here, and why is it in one-dimensional? It extracts local features from text sequences, acting as a feature detector. And we use one-dimensional because we don't. Okay, when we used images, we have two dimensionals of image. We had dimensionals for X dimensional and Y. So now we have only lengths of sequence, and dimensional for Y will be like we will not have it. So it will be a flattened vector, and because of this, we use one-dimensional convolution. Also, we have ReLU activations, which introduces non-linearity, allowing the model to learn complex patterns. And also, we have max pooling, where we have it. Okay, we have adaptive pool. Why do we need it? Because it reduces sequences to a fixed size by selecting the most important features, ensuring consistent input to the fully connected layer. And also, we will have flattened vector here. We need it because it converts to multidimensional tensor into a two-dimensional shape for the final linear layer. And so in all of these layers will consist our final model. Okay, we have put the device here, and we can move it to our CUDA device. Also, we will have training loop. We define optimizer. We have here Adam optimizer and loss function. We will this function will measure the mean squared error between predictions and actual salaries. And why do we use Adam optimizer? It's maybe you will say me what is Adam optimizer and how does it works? If you remember this information, maybe from the lectures, or I don't know. I think somewhere you had this. Okay, so if nobody wants, it just combines benefits of two popular optimization algorithms. It's AutoGrad and RMS probe, and providing efficient and adaptive learning. Okay, do you remember what is MSK loss?
Yeah, this is mean squared error loss.
Yeah, I think I said it in previous minutes. Okay, yeah. So we measure average square difference between predictions and targets. By the way, can you answer for this question? How will you choose between MSE loss and MAE loss when you will use each loss in the training? Okay, so if nobody wants to answer, I just want make you questions, which will be, I think you will have a lot of questions on this topic later when you will work and maybe when you will have interviews to the work. So yeah, MSE loss. We can use MSE loss when we will have data set with oh my god, how to say it? Okay, when we have more. When we have a smoother distribution of our dataset, I mean that we will not have maximum variables in our dimensional. We will have normal dimensional without any maximum variables or too small variables in the dataset. When it's when it's smooth, we can use MSE loss. When we have too big variables in the dataset or too small, we need to use MAE loss. Is it clear?
Yeah, thank you.
Okay.
Yeah, may I ask you to make an
Yeah,
example?
of course. Example of usage.
Yes, of a real usage case.
Do you mean when we use?
I mean, some real situation when we need to use between MSE and MAE.
Yeah, of course. When we have, for example, linear regression task, when we want to predict a number, not a class of something, we need to choose between all the losses which we can use with variables. I mean, with linear regression, and in this case, we need to choose between MSE loss and between MAE loss. Sometimes MAPE, WAPE, and others. Also, we have Hubert loss there. I think. I'm not sure. So yeah. Maybe we can we want to predict I don't know, maybe we want to predict age of person who use our marketplace or our app. For example, we have only we have their history purchases. We have categories of these goods. Maybe we know wish list of this person, and on this information we can we want to predict age of the person. It will be a linear regression task. So in this case, we need to analyze our data set. We need to understand which distribution we have in this moment. we will choose our loss consist with our distribution and maybe other factors that we analyzed in our EDA. Okay, its name EDA process when we analyze data set that we have before start to create our machine learning system.
It's explorative data analysis.
Yeah.
Mhm.
So, okay, here we have batch size, what we want to use in our training loop. Also, we have, okay. We have function to get our metrics from evaluation stage. And what do we have here? We want, okay, it's, I think it's mean squared error, yeah, of mean squared error and mean absolute error of validation samples. We have here some metrics which was previous on our training loop after our training loop process. So it's kind of normal metrics. I don't know, just for a simple task, it's okay. But at home, maybe you can try to ensure these metrics. Okay, what do we have next? Okay, maybe what do we have 30 more minutes. So maybe let's do like this. I will stop sharing my screen. We will try for 10 minutes to create a code for a notebook. Then I will continue sharing my screen, and then we will discuss maybe some issues which was in code creating, and maybe we will discuss some more moments. What do you think about it?
We can do some transformations on the sentences. So here we have built the search engine of the similar sentences. Generally, I think that's it. If you have questions, we can then discuss them. And otherwise, this is basically the idea of the first segment.
Okay. So okay, let's just share it, the screen.
It's not be in the wrapper, right?
Huh?
In the course.
Sorry, what's the question? Will the notebook be in the repository?
Right.
Yeah, so it will be uploaded in the repository. I will create the repository for the course this week, and we'll try to operatively publish there the lectures and the seminar materials and the assignments.
Thanks.
Okay, do you hear me?
Yes, we can hear you, sure.
So that was some okay. Lecture started and I messed up all of the stuff that we had. Okay, I can share the screen and let's check all the tasks that we had here. So let's start with our three inputs net. Here we had class. Okay. Did you finish the code?
Personally, me not, because I had to run all the cells and
Okay, do you want some more minutes for this? We have 20 minutes left, so I think that we have a lot of time just to do all of missed code blocks and other.
personally, I'm not against it.
Okay. Okay, let's wait for maybe 5 more minutes. Okay, let's discuss what we have here in the code space. So first of all, I think we can start with initial of our convolution network. First, we have embedding layers, title, embedding layers of title, embed, and full embed. It means that we have two embedding layers for the title and for the full text. We convert input token indexes into dense vectors of dimension hidden size. Here we have this dimensional. So they act as lookup tables that maps each token to a vector representation. Also, we have convolution networks. Here we can see it. These layers extract features from text by sliding over the input embeddings, capture local patterns. Also, we have adaptive max pool. This reduce the sequences, of convolutional outputs into fixed size vector by selecting the most significant features. And we have layer for category features, which process categorical input features into dense representations of the same hidden size. Here we can see it. And also we have fully connected layer which produce final output. Also, okay, is it clear? If we will talk about forward process, I think more significant space that we have here, and what can be not clear for you, it's permute operation. So it changes the dimensionals of embedding input that was embedded input to compatible with the convolution layers, and PyTorch have conf1d function that expects the input to be in the shape of batch size, channels, and sequence length. Because of this, we need to have permute operation, which will just mix up all dimensionals. Also, it may be unclear for you, torch cat. It's concatenation. We merge the process title, full text, and categorical features in the single vector before passing them through the final fully connected layer. After this, we can pass it in our fully connected layer linear that was in the end of our model. So here you have two more spaces to implement alternative model using RNN or LSTM to handle the text instead of CNN. And I can explain you now maybe how to do it. And
yeah, it'd be great. Thanks.
Yeah, and you can try to do it at home. So let's just write a pseudocode, kind of pseudocode, and then you will just at home you will do it clearly and try to run of all of the operations, and maybe you will try train it. So you will have a class for RNN. I will not type here all the models what we need to import here. I will just okay. I will skip init. I will just type something what will be close to init in PyTorch. But then, of course, you should at home type and super and clearly initialize all the functions. In the beginning, I think you need to initialize embedding lawyer for title and full text. And it will be kind of that we had earlier. We can just copy paste it. For example, you will have self title embed for titles and for full texts. Then you need to provide LSTM lawyers for title and full text processing. Okay, it will be something like this. And you need to pass their input size. Also, you need to pass the hidden size. And also, you need to pass their kind of this operation. First. Okay, true or false. Do you know what will be input size here?
It would be size of our embeddings.
No, sorry. It will be hit size here and here. And also we can pass the same the same lawyer for full text. So, and we will have lawyers like we had previous category lawyer and for output lawyer. It wouldn't change. Now we just have, instead of convolution lawyers, we have LSTM lawyers to capture sequential dependencies within the text input. And I'm gonna to explain you how to create forward here. You need to provide okay, firstly, you will have, let's just change this forward. You will provide this line of code like you had, but then we will change this this part of code. we will have let it be title. It will be sorry. Okay, also you will have oh no, input one. Okay, title embed. Yeah, and now you will have like this separation for LSTM lawyer. Title. And then you need squeeze it. Also, you need to do it with full text layers. It would be something like full embedded. Here we will have input 2. And then we will have and also squeeze. Then we will have we will not do something with this line of code. And you'll have it would be wrong for RNNs because you didn't do with dimensions anything. So you need okay, concatenated. Concatenated will be equal for category. And you need to provide dimensional. So in this version, LSTMs process sequential information, and it will make more suitable for task where understanding the order of tokens is important. So, and you will have bonus area for fixing the data leaks. We haven't time for provide pseudocode for this for this task, but you need to use this library for this. You can just Google documentation for its usage, and you can do it at home. It's not difficult. It be around I don't know 7 line of code, and group of scaffold will ensure that all data points from the same group are not split across training and validation sets, preventing information leakage. So now we will have we don't have time for more tasks. Maybe you have questions.
For this class RNN for the in the method forward, what is exactly in the whole input? You know, there are kind of three components: input 1, 2, 3, right? And what are them? Is it just like sequentially parts of the sentence, or what is exactly? Input 1, input 2, input 3 equal to whole input. That's just the second line in the function forward.
Okay, yeah. So it's represent of input features that we have in pre-inputs net. We had it. 1 second. Yeah, we had it.
Okay, yes. I got it now. Thanks.
You're welcome. Okay, if nobody have questions, we can stop our lesson, and thank you so much for attention. Yeah, and
yeah,
so,
maybe one more question. Where can I get this notebook practice 0 to CNN?
0 to CNN. It was in GitHub repository. I think I provided a link for you, but I will do it right now one more time.
In Telegram or here?
I don't remember. I think here.
If you could please share it in Telegram, it would be very welcome.
Yeah, okay, no problem. So I will share it right now in our chat.
Super, thank you.
I shared link, and I think everybody should see it. So
Yep.
also I want to refresh information about homeworks. I provided a link for Google Form with first homework in that Telegram chat, and I would just that everybody saw it, and everybody have this information. I want to make sure about this.
Yes, we saw it.
Okay. Thank you so much. If nobody have questions, now we can just stop our lesson.
Thank you very much.
Goodbye.
Thank you. Goodbye.